Hello, welcome to Notes 7.05. And we're also going to do a quick um, intro to Note 7.06 as well. Okay. Uh, Law of sines, okay, is different than sine, cosine, and tangent, meaning SOHCAHTOA. Okay. So SOHCAHTOA is used only when we have right triangles. But as you see in these two pictures here we have an acute triangle ABC with angle A, angle B, angle C. Across from each angle is a side. And notice the sides are little a, like a lowercase b, and a lowercase c. Right? And those are each side. Now side A is opposite the angle at A. Side B is opposite the angle at B. And side C is opposite the angle at C. So this again is an acute triangle. This here, angle C, looks more than 90. This would be an obtuse triangle. And when we have acute or obtuse triangles, we're going to be using the law of sines. When it's a right triangle, we use SOHCAHTOA. Okay? So law of sines is used when you're given sides or angles of what's called oblique triangles, when there are no right angles. Okay? So how this works is the proportion goes A over sine of angle A equals B over sine of angle from B, and side C over sine of angle C. So in the numerators go side measures, and the A, B, and C here are all the angle measures, right? We have 3 fractions here, but remember, we're only going to look at 2 fractions at a time, okay? So I'm just going to kind of box out these 2. And there are 4 pieces in your proportion. You're going to know 3 of those pieces based on a picture, and you're going to cross multiply to find the 4th. Right? So let's jump into an exercise. Exercise 1. Use law of sines to find the length of AB to the nearest tenth. Okay? So this is the side we're looking for. And this side X is opposite that angle of 86 degrees. So how we're going to put this in is that side X is opposite sine of 86 degrees. Okay. The other side we're given is 38 as a side. Again, that's what goes up in our numerator, and that is opposite the 51 degree angle. So that's going to equal 38 is the side over sine of 51. And from there, remember, this is some decimal value. If I just put in sine of 86, just says it's 0.99756. Right? So what we're going to do here is cross multiply. Now I'm going to handwrite this out first and only type it in the calculator one time. So when we cross multiply, we get x times sine 51 equals 38 times sine 86. I'm going to keep going with it. The sine 51 I need to undo from this side because these are being multiplied. We need to get rid of the sine 51 so that x is alone. So we divide by sine 51. And then that crosses out, so we're left with our x value. So all of this here is going to be substituted into the calculator. Now, something with multiplication and division. I like to use my fraction. So when we hit the alpha button, the screen button here, y equals and enter, it brings up that nice little fraction for you. Okay, if you have an older version calculator, I'll show you how to do that in 1 second. So 38 sine 86 over sine of 51. Type it all in, and it gives you an answer. Okay. So again, I'm going to approximate that. Here, write it out to the 4 decimals, so 48.7777 is going to round to the 10th place to be 48.8. The final answer here is 48.8. Now, in the context of the problem, let's go back into the picture for a second. Does that make sense here, that this side is 48.8? Well, that's longer than the 38 that we were given, okay? And that makes some sense because a longer side is opposite the larger angle measure. This 38 is opposite the smaller angle measure. If you don't have the fancy calculator to get the full fraction in, what you would do is type in the numerator, 38 sine 86, hit enter, and then divide by your denominator, sine of 51, and that gets you the same answer. Okay, so you could do it in 2 steps, evaluate the numerator, then make your division for the denominator. That'll help with your decimal. Exercise 2. Use the law of sines to find the length of AB. Now, another reason we would know this is the law of sines, besides them telling us it in the question, is if we add these angles, 53 plus 44, and we take 180, subtract your 97 degrees, the third angle here is 83. Okay? So we don't have a right angle, meaning we can't use SOHCAHTOA. With that SOHCAHTOA, you have the hypotenuse is always that known side across from your right angle. Okay? We don't have that if we don't have a right angle. Okay? And they're asking for the length of AB. So that's where I'm going to put my variable. Okay? So this side is opposite the 53, and the 7 they gave me is opposite the 44. So we're going to say x over sine of 53 equals 7 over sine of 44. Cross multiply, x times sine 44 equals 7 times sine 53. Gotta get x alone, so we move the sine 44 over. And typing that in, I'm going to do 7 sine 53 is my numerator, divided by the denominator is sine of 44. X approximates to 8.0477. Into the hundredths place is where the 4 currently is. So this is going to become 8.05, rounded to the hundredth. And again, I like to go back into my picture, see if that makes sense. Is this side going to be longer than this side? Yeah, that x is across from a 53, where the 7 is across from something smaller, 44. One other thing, if I didn't already say it, if you're not getting the same measures, make sure you're checking your degree mode. But I think by the couple days into this unit, you guys can do that. Okay. I'm going to skip exercise 3 and 4 for timing today, and I'm going to jump down to where we can use this for a double triangle problem. Okay. Now, this isn't just double triangle. This is actually triple triangle. There's 3 triangles in this picture. There's the big right triangle, ABD. There's a small right triangle. And now we have this oblique triangle here, okay? This obtuse triangle. So what we're going to do is, first step is to find all angle measures. So we did this way back at the beginning of the year. I gave you a big crazy kind of picture, and we'd had supplementary angles. We had right triangles with missing angles, okay? And kind of led to this type of question. After you find all your angle measures, then we're going to redraw our triangles. And step 3, you're going to use one answer to 4 decimals to find the next answer. So looking at this picture, for the figure below, find BC to the nearest whole number. So BC is the length that they're looking for. So that's where I'm going to put my X for now. But in that triangle, that's a nice little right triangle there. It'd be easy if I had the hypotenuse or if I had AB. So if I knew AC or AB, I could easily set up a trig function, sine, cosine, or tangent, adjacent to opposite or adjacent to the hypotenuse, and go from there. So what we're going to do, again, first step is to find all of our angle measures. Okay, so we need to use this purple outline triangle here in order to help us with this other one. So these 2 angles, as I said before, add to 180. So 180 minus the 65 is going to give us 115. Yes, I'm typing it in just to triple check myself. Well, now that purple triangle, I have two of the angles for. If that angle is 115, and this angle is 20, 180 minus 135, those add to, leaves us with 45 degrees, I believe. 180 minus 135 is 45 degrees for this teeny tiny piece up here. So I have those three angles. Now, for this right triangle here, I have 65 degrees. Well, 65 minus 90 is going to leave me 25 degrees. Yep. And therefore, the big triangle has angle B, 90, plus angle A, which is 25 plus 45, plus the 20 degrees at D over here. If we look at the big picture, those still add to at 180. Okay? So now I have all my angle measures. Second option is to redraw. Now I know I'm going to start with the purple triangle because I have a given side length here. I know that this side down here is 15. So I kind of redrew that purple triangle down off my paper to leave myself some space. I know this is 15, this angle is 115, this one's 20, and this angle is 45. So I'm translating this diagram down my paper. So translations are rigid motions we did earlier this year. Then that triangle has this hypotenuse kind of already as one of its sides. Okay? That this side and this side match each other. That's going to help us, that reflexive side, it's going to help us find something in the orange triangle. Not drawn as nicely. Ooh, that's really bad. Yes, I just used whiteout to take that out. Here, this one's better. Okay. So in the orange triangle, we have angle at B is 90, this one is 65, and this one is 25, and we're asked to find side X. Okay. So again, I can't start with the orange triangle. I don't have enough information, so we're going to start here with the purple. And what we're going to do is we're going to find this side A. I'm going to use A over sine 20, B over sine B. Then we're going to repeat that answer to here for the hypotenuse. And then we're going to use the orange triangle. So we're going to start with law of sines. So from the purple triangle, we're going to say that this missing side A is to sine of 20, as the 15 is to that 45. So the 115 we don't use within our proportion. If I needed to find this long side, I could have. So we're going to say that 15 is to the sine of the angle 45. Okay. So I set up a proportion using the purple triangle. Again, we needed to use the law of sines here because it's not a right triangle. It's an obtuse triangle. So cross multiply A times sine 45 equals 15 sine 20. Divide yourself by sine 45 on both sides. And A will equal or approximate to 4 decimal places. This is not a final answer. It's an intermediate answer, one answer we used for the next. So we need to use 4 decimal places here. So 15 sine 20 divided by sine 45 gives me, sorry, that was off the screen. So multiply the numerator divided by sine 45, the denominator, is 7.2553. 7.2553. And that measurement is my hypotenuse here. So I'm going to rewrite that here, 7.2553. Now we're going to go use that answer in the orange triangle. Okay. So if you want to redraw one more time, just that visual of a person, for explaining purposes, if we're trying to find side X, and the angle between us is 65 degrees, we have the adjacent side and we have the hypotenuse. Okay. Now there is a 25 kind of hidden up here. We could use law of sines. Okay. So what I'm going to talk about is this is a trig function. We have the adjacent side we're looking for. We have the hypotenuse. So we could say cosine 65 equals x over that 7.2553 and cross multiply. But I'm going to set up another law of sines here. Just to show you, law of sines actually works for all triangles. So our law of sines would be x is opposite the 25-degree angle. So we have x over sine 25 equals the hypotenuse we have over sine 90 is 7.2553 over sine of 90. So when we cross multiply, x times sine 90 equals 7.2553 times sine 25. When we divide by sine 90, cancels itself out. So x equals, one thing I'm just going to type in here and show you something. Sine of 90, it's just 1. So that denominator right now, the sine of 90, is just the number 1. So really, we're just taking the 7.2553 and multiplying it by sine of 25. Gets me approximately 3.0662. And to the nearest whole number is going to be x equals 3 for the final answer here. Okay. Now some of you are saying, but Miss Locke, you have cosine right there. Well, this sine of 25 is that decimal that I just multiplied here. Guess what cosine of 65 is? Where these two numbers add to 90, those two decimals are equivalent to one another. So the next notes page I'm going to kind of flip over to kind of goes over this idea. Okay. So I want to skip the classwork page for now and have you go over to notes 706 for me for a second. What I want to talk about is sine and cosine. So notice those say the same thing. The word CO is just added to the beginning there. Okay. What that means is they're complementary functions. Complementary meaning both things always add to 90. Okay. So if I look in this triangle, we have a right triangle, ABC. There's a person standing at B and a person standing at A. The angle of elevation up to B is 22 degrees, making this angle here 68 degrees. A person is a distance of 15 to something. These two people are about 40 apart. And part A asks to find the length of AC. Well, that is the third side of the triangle. You could just use Pythagorean theorem. X squared plus 15 squared equals 40 squared. So 15 squared, 40 squared gives me 225 and 1600. So x squared plus 225 is 1600. And move that over. We get x squared equals 1375. And here we take the square root of both sides. X to the nearest integer is going to be 37 for our purposes today. So knowing that this is 37, okay, we can fill in some ratios. Sine from angle A. If I focus on angle A, my opposite side is 15. My hypotenuse is 40. 15 over 40. Cosine from A is the adjacent 37 over 40. Adjacent over hypotenuse. But what if I focus on a different angle at B? So if I focus on B, this is my adjacent side, and now this is my opposite side. So sine of B is opposite 37 over hypotenuse 40. Wait a second. Those two things are the same ratio. So cosine from one angle equals this fraction. Sine of a different angle equals that fraction. They're equal. And cosine from B is my adjacent side, 15 over my hypotenuse, 40. Those things are equal. And that's always going to be true. So that kind of leads us to this rule. If angle A and angle B are acute angles of a right triangle, then sine of A equals cosine from B, where angle A plus angle B equal 90. So this measure and this measure will add to make 90. So if I have sine of 20, that's going to equal cosine of its complement. So again, these are called complementary functions, meaning these two measures, A and B, 68 and 22, add to 90. Okay? So if I take 90 and subtract 20, I get 70 degrees. And again, these are two decimal equivalents. Sine 20 is 0.3420. If I type in cosine 70, okay, those are equal to each other. Sine of 55 is equal to cosine of what? Okay, so 90 minus 55 is going to be 35 degrees. Okay. Careful with your subtraction, okay? I'm working on these. We borrow here. 10 minus 5 is 5. 8 minus 5 is 3. Some of you do your subtraction from the 10s first and then the 1s second. You gotta be careful. So sine of 55, just to check, cosine 35 equal, we're good. That's nice when we find the complements. I'm going to kind of skip the rest of those for now. Based upon these findings, we can also say sine of x equals cosine of 90 subtract x is how we just found that. We took what this was and we subtracted it out. And same with cosine of x equals sine of 90 subtract the x, where x and this one always add to make 90. So x plus 31 gives us 90, making x equal to 59 degrees. So we got to subtract 31 over. Subtract 30, you get 60. Subtract one more, you get 59. So when these are an expression, sine of a number minus 4 equals cosine of 50, these two things add to 90. So if we write x minus 4 plus 50 equals 90, well, minus 4 and 50 is plus 46 equals 90. You get 44 degrees is x. Ooh, if I can have that on the screen. So again, sine of one angle equals cosine of its complementary measure. That's what I'm going to say about note 706. There's a classwork that kind of goes along with this. We're going to skip that one for now. The intended classwork for today is classwork 7.05. So just as always, we like to have you try this on your own. Okay. What is the main difference between the new law of sines? Remember, is like A over sine A equals B over sine B. You might want to reread the beginning of our notes. Find AB to the nearest whole number is x. Something else I'm going to help you with for number 2 is we got to find all the angle measures. Okay. So if I take 180, subtract the 101, subtract the 63, the other leftover angle measure in here is 16. And that's what's opposite this 9. So that should help you set up your law of sines. Again, it's an obtuse triangle, so we need the law of sines. Same thing with number 3, find all your angle measures first. I gave you the hint there. Number 4, my hint to this question, you could find this distance from the 2 cars is what you're asking for. That's the measurement you're looking for there. But you cannot use the law of sines. So this is similar to another question where you're going to find a missing part here and a missing part here, and x is going to equal the sum of those. Right? So you do have to see this as a right triangle to the left and a different right triangle to the right. So again, we want to make you think with these. So make sure you have some work shown there. Question number 5 is similar to what we ended our notes with today, a double triangle problem. You're going to start with this orange triangle here. Find all your angle measures, go from there. But you're going to start with the orange one, where you have 150 feet here. And then the second right triangle shares this side. So you're going to find this side and utilize it in the second right triangle. So you're going to start with law of sines, and then you're going to move to a little SOHCAHTOA. Questions 6, 7, and 8 are pretty self-explanatory, so mixed review. One thing I do want to say, you're going to need a picture for number 6, but looking ahead to number 7, I do want to say this. Cosine E equals 4 over 7. What that tells you is 4 is the adjacent side to E, and 7 is the H, the hypotenuse. So cosine of E means the adjacent side is 4, and the hypotenuse there would be 7. Might help out. Good luck. Email me with questions. And we are moving forward to a quiz here soon. So make sure you're checking Google Classroom.